Hi, y'all. Today we're dividing roots and rationalizing the denominator. So dividing roots is the first part here, and it's going to be a lot like multiplying. And then rationalizing is something that we are going to try that might be new today. So when we are dividing, we're going to divide outsides with outsides and insides with insides. So just like we were doing before, we're going to divide the coefficients together, right, or against each other. And we're going to divide the radicands against each other, right? So if I'm looking at this first problem here, I'm thinking, okay, 12 divided by 2 would give me 6. And 160 divided by 5, I can do this in my calculator, or I know this would be 32, right? So root 32 on the inside. This is a square root, so I'm going to be looking for pairs when I break this down. I know it's 8 and 4, 2, 2 and 2. Here's 2 and 2 as well. So I'm going to cross out the things that have already been used up. Okay. And I'm looking for pairs, so groups of 2, since that's my index. So 2 here, and we have 1 left over. So that original 6 is going to come down. We have a set of 2's, making a 2 here, set of 2's, making a 2 here, and a leftover 2 inside. Multiplying 6 times 2 is 12, times 2 is 24, root 2. This would be the simplified version for number 1 here. All right, so outsides with outsides, insides with insides. The same is true if we're working with our higher powers, right? So our higher orders. Higher order root is 4 here, but we're still going to do outsides with outsides and insides with insides. We just have to make sure that they have the same root. So since they're both fourth roots, we can do this. So 36 divided by 9, that would be 4. And then 250 divided by, or 1250 divided by 2 would be 625. So I have fourth root of 625 left over. Right, so outsides with outsides, insides with insides. Now we need to simplify. So I'm going to have 625. I know it's 5 and 125. You could just divide the first until you find the right one. 5 and 25. This is 5 and 5. So I'm looking for 4 of a kind, right? So since I have an index of 4, I need 4 of a kind. So you have 4 5s here, all coming to the outside. The 4 is coming straight down from the outside already. And there's nothing left over in this root, so I don't need to write the root anymore. So then I would just do 4 times 5, which would give me 20. My correct answer here is the number 20. Okay. So for dividing, really just outsides with outsides, insides with insides. We can do it with square roots, cube roots, fourth roots, even fifth roots or more. But we follow the same rules for simplification as in the past. So the second part of this lesson is about rationalizing the denominator. The real idea, the reason that we don't use or that we rationalize the denominator is that in a time before calculators, mathematicians didn't want to divide by a radical because it's super hard. So imagine this idea. If I could divide square root of 2 divided by 2, or I could do 2 divided by square root of 2. It's much easier to divide something by a whole number than it is to divide by a fraction. Imagine this is like 2 divided by 1.414, yada, yada, yada. I don't really want to divide by that. So they came up with a way to rationalize it, which means to get rid of the radicals in the denominator. So we're not allowed to have a radical sign in the denominator, right, in the bottom of our fraction. So there are 2 ways that we're going to think about this. One is if there's a plus or minus, or well, we have to look to see if there's a plus or minus here. If there's not, it's pretty simple. If it is, we have to use a slightly different method. So if there's no plus or minus in the denominator, then we're just going to multiply the numerator and the denominator by the radical. So for example, in this first one, if I multiply the denominator by square root of 3, I also need to multiply the numerator by square root of 3. Remember, just as a side note, this equals 1, right? So we're really just multiplying times 1, right? So it's not changing the problem, just changing what it looks like. So I would have 1 times square root of 3 would just be square root of 3 over square root of 3 times square root of 3 would be the square root of 9, which is just the whole number 3, right? So this together, remember, makes square root of 9. Square root of 9 is 3. So this is our rationalized answer. Is it really more simple than this? Not really, but it is easier to do by hand, which is why the mathematicians liked it. So we have a similar problem for number 4, but this time we have a 3 in front. You might be thinking like, oh, I'll just multiply by 3 root 10 and 3 root 10. That's going to make it like unnecessarily complicated. We can just multiply by square root of 10 on top and bottom. So that's going to look like this. I'm going to have 2 root 10, and then I'm going to have the 3. Remember, outsides with outsides, 3 times 1 would be 3, and square root of 10 times square root of 10 would be square root of 100. Square root of 100 is whole number integer 10. So I have 2 root 10 over 30. And then if I can, I want to simplify. And I know I can divide both of these by 2. So I get 1 square root 10, or just square root 10 over 15. Like that. So this is the simplified rationalized version of this. Again, remember, the whole point is because I don't want to divide by square root of 10. I don't even know what that decimal is, but I can pretty easily divide by 15. Right, so that's why they wanted to do that. All right, so if there's just a radical in the bottom, we just multiply by that radical on top and bottom. If there is an addition or subtraction in the bottom, it becomes a little bit more complicated in order to get rid of the addition or subtraction. So we're going to use something called a conjugate. So this right here is a conjugate pair, right? It's a conjugate pair. They basically help to cancel each other out. So if I multiply them together, they're going to cancel. So what I'm going to do here, so I'm going to prove it to you. So if we have the square root of 5 plus 1, we're going to use the exact same thing, square root of 5 minus 1. That's going to go on top and on bottom, just like that. So for the top, right, when I multiply these times each other, I'm going to use my distribution. So the numerator is going to be 2 times the square root of 5, 2 root 5, and 2 times negative 1, so minus 2. That is my numerator. My denominator is a binomial times a binomial, which, as you might remember, is the box. So I'm going to go down here and use the box, square root of 5 plus 1, square root of 5 minus 1. Square root of 5 times square root of 5 would be square root of 25, or just 5. Square roots kind of like cancel each other out. I have square root of 5 times 1 would be positive square root of 5. Square root of 5 times negative 1, negative square root of 5. And negative 1 times positive 1 is negative 1. What should always happen when you have the denominators, a conjugate pair here, these should always cancel. If they don't cancel, you've done something wrong, right? Or you don't have a conjugate pair. Those should cancel. Square root of 5 minus square root of 5 would make 0, right? And then you would just have 5 minus 1 would be 4. So 4 goes on the bottom of your denominator, right? One thing to notice here is this is basically our answer, but it can be simplified because this number, and this number, all of the coefficients, right? All the coefficients are divisible by 2. So I can divide that by 2. I can divide this by 2. I can divide this by 2. So I'm like simplifying here. So 2 divided by 2 would be 1 square root 5 minus 1. I could leave the 1 there. I don't need to. Over 2. Right, so this would be my final answer for the simplified version of this here. Did it take a lot of work? Absolutely. Is it less complicated to divide by 2 rather than dividing by square root of 5 plus 1? Absolutely. So that's why they would have taken this process. Okay. If you want to pause the video and try this last one on your own, you're welcome to, but I'm going to jump in here. So I have the square root of 2 minus 3. So I'm going to multiply times the square root of 2 plus 3 on top and on bottom. So first thing I notice is that the numerator is also a box here. So I'm going to have to use an orange box, and then I'll also do a green box for the denominator. All right, so orange box first. This will be 4 root 2 square root of 2 times 3. So 4 times root 2 is 4 root 2. Square root of 2 times square root of 2 is the whole number 2. 4 times 3 is 12. And 3 times the square root of 2 would be 3 square root 2, like that. That is going to be my numerator. And then my denominator would be square root of 2 minus 3, square root of 2 plus 3. Square root of 2 plus square root of, times square root of 2 would be 2. Negative 3 times square root of 2, negative 3 square root of 2. Positive 3 square root 2. And negative 3 times positive 3, negative 9. This is good news that these are canceling because this is my conjugate, right? So those would subtract to 0. So I just have 2 minus 9 on the bottom. So when I go back to my numerator and denominator, I know that 12 and 2 would make 14. And I know that 4 root 2 and 3 root 2 could be added together to make 7 root 2. That is my numerator. My denominator is here. I have 2 minus 9. 2 minus 9 I know is negative 7. Right, so this is my answer. I have my numerator and my denominator. The only thing I might need to do is simplify, and I can see that I can divide this by 7, by 7, by 7. I don't need to worry about the inside. So 14 divided by 7 is 2, plus 7 divided by 7 would be 1, square root 2, over negative 1. Anytime that we have a negative in the bottom, it can be applied to both the top parts. So I would have negative 2 minus square root of 2 would be my simplified answer for this division problem here. Pretty complicated. Please ask any questions that you have. Thanks, y'all.